Okay. A post is held in vertical position by three cables AB, AC and AD as shown in the figure. So here you can see a post, this particular one that is in blue color. This is a post and it is placed vertically along the y-axis. So the floor is XZ axis and this pillar or the post is kept vertically upward in the y direction by using three cables, that is AC, AB and AD respectively. Then if the tension in the cable AB is 40 Newton, calculate the required tension in AC and AD so that the resultant of the three forces applied A is vertical. Okay, that means here in the question it is given the tension in the cable AB as 40 Newton. That is, the tension in this cable, this particular cable is 40 Newton and it is acting in this particular direction, that is from A to B. So the cable is connected from A to B, also to C and D, and using these cables what we do is we are making the post perpendicular to the floor or along the y-axis. That's why it is given that the resultant is acting vertically downwards. It is acting vertically downwards means the pillar is kept perpendicular. Okay, so the force at A due to these three cables will make a resultant force acting from A to this particular point, let it be O, which is the origin. So in order to solve that, what we have to do is we have to consider the force vectors along AC, AB and AD. We will get three force vectors and we have to find the resultant out of that. That is, first of all we have to find the coordinates of the points, that is O, A, B, C, D. We have to find the coordinates. Then using these we have to find the unit vectors along the three directions of the cable, that is N, AB and not NBA, NAB itself, because the force is acting from A to B, A to C and A to D. So we have to find the unit vectors NAB, NAC and NAD. Then using these we have to find force vectors FAB, FAC and FAD. And here for FAB you know the magnitude, that is magnitude is 40, and for FAC and FAD we don't know the value for the magnitude, so we can put the value as FAC and FAD as such and substitute the values, and after that by just adding you will get the resultant vector as something in the format RXI plus RYJ plus RZK. In this format you will get, and you here you will have some variables, that is FAC and FAD, which is unknown. So in order to find that, we know this thing, that is the resultant of the three forces at A is vertical, that is it is acting along the y-axis, it is acting perfectly in the y-axis. So it is perfectly acting in the y-axis, that means Rx and Rz are 0. So by equating the terms of Rx and Rz as 0, you will get the unknown values. Okay, so we will find how we can solve that. So here are the coordinates. So from that you can easily find the unit vectors along the direction AB, that is NAB that is you will get 16i minus 16i minus 48j plus 12k divided by root of the corresponding terms, and you will get the value as 52. Similarly, NAC, unit vector along the direction AC, as 16i minus 48j minus 24k divided by 56, and also NAD as minus 14i minus 48j plus 0k divided by 50. Now, using these values, you will find the force vectors FAB. So, vector FAB will be equal to, the magnitude of FAB is 40. So, it is given in the question, that is 40 Newton. So, you just multiply by 40, that is 40 into 16i minus 48j plus 12k by 52, and on solving you will get 12.31i minus 36.92j plus 9.23k. Similarly, for vector FAC, you will get the final answer as 0.29i, not I, into FAC into I, because FAC is unknown, minus 0.86 FAC into J minus 0.43 FAC into K. And for vector FAD, it is minus 0.28 FAD. Here also FAD is unknown, minus 0.96 FAD into J plus 0k. Now you got the three force vectors. Now you have to add these to get the resultant vector. So resultant vector will be equal to FAB plus vector FAC plus vector FAD, and we are adding these. So corresponding terms of i's, j's and k's, and you will get a value, final value as, that is first I terms, that is the first terms, that is 12.31 plus 0.29 FAC minus 0.28 FAD into I plus now the y components, that is minus 36.96 minus 0.86 FAC minus 0.96 FAD into J, then the Z component, that is sorry 23 9.23 minus that is 0.43 FAC plus 0 into K. So these are the resultant vector, and from here you can see this is Rx, this is Ry, and these terms are Rz. So since the resultant is acting vertical, that is, you can say, since the resultant is acting vertical, then you can say the other components, that is Rx equal to 0 and Rz equal to 0, because vertical direction is y axis, so it is acting only in the y direction, so the other components will be 0. Now you can use these relations from this to solve that. That is, Rx equal to 0 implies, you can say 1 to 12.31 plus 0.29 FAC minus 0.28 FAD equal to 0. This is one equation. And next, Rz equal to 0 implies 9.23 minus 0.43 FAC equal to 0. This is equation number 2. And on solving 1 and 2, we get FAC equal to 21.47 Newton and FAD equal to 66.2 Newton. Okay.